If you Google famous physicists, you'll be faced with a long list of people who have contributed to our understanding of many problems in physics over the centuries. Of this entire list that comes up on Google, I found one woman. Oh, and also one person that wasn't white as well. That's not exactly representative of the world we live in, but unfortunately it probably reflects sort of the average general public's perception of who does physics. A European study in 2014 found that when asked to name a single female scientist, 25% of respondents couldn't. Name a single one. By far the most popular answer was Marie Curie, who appeared in our list from Google before as well. A double Nobel Prize winner in both physics and chemistry and famous for her work on radioactivity. But apparently beyond Marie Curie, even Google is hard-pressed to name another female physicist. So I figured today I would make a list of 10 great female astrophysicists and astronomers from history. Not even just physics or science. We're talking about narrowing it down to just my own field in astrophysics and astronomy. And even that was incredibly difficult to narrow down to just 10. So if you think I've missed somebody and there should be somebody else included on my list of 10 famous astrophysicists from history, then let me know in the comments below. Let's start with Laura Bassi. She was an Italian physicist who lived from 1711 till 1778 and is a woman of many firsts. She was the first ever woman to achieve a doctorate degree, i.e. a PhD in the sciences. She was also the first woman ever to be hired, i.e. paid to teach at a university, albeit to all male classes, and the first woman to be elected to a scientific society in 1732. Her work was focused on understanding Newton's ideas of gravity and then also Franklin's ideas of electricity and bringing that work to Italy and conducting further experiments. She really was sort of the first trailblazer for women in physics, and no list would be complete without her. Next up is Caroline Herschel, who was a German-British astronomer who lived from 1750 to 1848. Now, it was originally her brother William Herschel that first caught the bug for astronomy, and given the culture of gender roles at the time, she was sort of roped in to be his assistant. In that role, though, she was really unhappy with all of the resources that were available to people doing astronomy, including Flamsteed's famous catalogue of stars that were in sort of constellation order. That was no use to her. Instead, she ended up making her own catalogue of stars and also her own Star Atlas II. All of that combined with William's efforts to develop better telescopes meant that in a single year alone she discovered 3 new nebulae and 8 new comets. She then wrote of those discoveries to the Astronomer Royal, which saw her being awarded from the Crown a salary of £50 a year, which is about 6,400 in 2020 money, for her work as William's assistant. It made her the very first woman to be paid in a role of government and astronomy. She was also the first woman to ever be awarded the very prestigious Gold Medal Award from the Royal Astronomical Society in 1828. This is Mary Somerville, and she was a Scottish astronomer and mathematician who lived from 1780 to 1872. Along with Caroline Herschel, together they were the first women to be elected to the Royal Astronomical Society in 1835. Her most famous work is Mechanism of the Heavens, in which she lays out the mathematics underpinning the workings of the solar system, building on Newton and Laplace's work, but also crucially translating that from the language of mathematics into common language as well. I guess a woman after my own heart. With this understanding, she was among the scientists that actually predicted that there should be another planet beyond the orbit of Uranus because of its strange orbit. She did this in 1842, 4 years before Neptune was ever discovered. She has an asteroid, a crater on the moon, and even an Oxford College named after her, as well as being featured on the Scottish £20 banknotes. Next up, Annie Jump Cannon, who was an American astrophysicist who lived from 1863 to 1941. She worked at Harvard College Observatory as a computer, one of the many women who were hired to sort through and catalogue the endless amount of images the observatory took. They essentially did the brunt work, the repetitive, tedious kind that we get computers to do for us today. The director of the observatory, Edward Pickering, actually set her the task of classifying all the stars in the sky over a certain brightness. She ended up classifying more than anyone in the world has ever done before. There were 350,000 stars. Problem was, there wasn't really any agreed way to classify stars at the time. And so she invented her own classification system based on what elements were present in the spectrum or fingerprint of light from that star. She classified stars as either O, B, A, F, G, K, or M stars and published her system in 1901. It's a system that's still in use today, with many an astronomy student taught the famous mnemonic, "Oh, be a fine girl, kiss me," to remember the order. Thing is, though, that classification scheme is called the Harvard classification scheme and not the Jump Cannon classification scheme. Next up, this is Henrietta Swan Leavitt. She was an American astrophysicist who lived from 1868 to 1921. She was actually a colleague of Annie Jump Cannon's at Harvard College Observatory, and both of them were deaf. The work that she was assigned by Edward Pickering was to catalogue all of the variable stars, this time in the Small Magellanic Cloud, which is sort of a little dwarf galaxy around the Milky Way. What she noticed while doing this work was that there was a correlation between the period that these stars pulsed at and how bright they were. Making the assumption that all the stars in the Small Magellanic Cloud were about the same distance away from us, she deduced there must be some sort of correlation between the intrinsic brightness of a star that is variable and the period which it pulses at. Now, this was published in 1912 under Edward Pickering's name, but thankfully in the very first line of the paper, it makes it clear that it is Henrietta Leavitt's work. Now, this correlation is important because it means that if you can measure the period that one of these stars pulsates at, then you know how bright it should be. Comparing that with the brightness that it appears to be to you, you can therefore get its distance. The thing is, they didn't know the distance to the Small Magellanic Cloud at the time to actually be able to calibrate that. They had to wait until that was measured separately using a method called parallax. But once that happened and Leavitt's law had been calibrated, it could be used to find the distance to many different types of variable stars, including by Edwin Hubble to find the distance to Andromeda and prove that actually Andromeda wasn't a spiral nebula in our own Milky Way galaxy, but actually a galaxy in its own right. A result that unfortunately Henrietta Leavitt did not live to see, but would not have been possible if not for her work. Next up, Cecilia Payne, who was a British-American astrophysicist who lived from 1900 to 1979. She went to Cambridge University in 1919 to study physics and chemistry, but was never actually awarded a degree because although Cambridge allowed women to attend, it didn't actually award a certificate degree to women until 1948. After she graduated, she realised that in the UK, the only opportunity for her was to become a teacher. And so instead, she moved to the US, again to Harvard College Observatory, where the new director, Harlow Shapley, had actually set up a graduate programme for women at the Radcliffe Observatory. And so she became the first woman to earn a PhD at Radcliffe College in 1925. Her PhD thesis was all about the composition of the sun, i.e. what is the sun made of? She spent many years looking at the spectra of light, the fingerprint of light from the sun, and concluded that it must be made of hydrogen and helium. That idea was dismissed, though, by the academic community, including her thesis reviewer, Henry Russell, because it was against the accepted hypothesis at the time that the Earth and Sun were made of very similar things. Of course, Henry Russell then went on 4 years later to do a similar experiment, found the same thing as Celia Payne. He published a paper on it where he said as much, but also referenced Celia Payne's earlier work, and yet still it's Henry Russell that is often mistakenly credited for that result. Next in the list is Margaret Burbidge, who is a British-American astrophysicist who lived from 1919 to 2020. She was the first author on a paper in 1957 that completely changed how we understand stars. It stated that all elements in the universe are created inside stars, a process that we call nucleosynthesis. So that often parroted phrase of, we're all made from stardust essentially comes from Margaret Burbage's work. She also went on to study quasars, discovering the most distant astronomical object known at the time. She also helped to develop the faint object spectrograph on the Hubble Space Telescope, an instrument that has been used for many a scientific result since it was launched. On top of all that, she was made director of the Royal Greenwich Observatory in London and elected the first female president of the American Astronomical Society, all the while campaigning against the discrimination, both positive and negative, of women in the sciences. Then we have Vera Rubin, who is an American astrophysicist who lived from 1928 to 2016. During her PhD at Georgetown University, she studied galaxies and found that they like to clump together in the universe. Again, this was dismissed by the academic community at the time as a very controversial idea, but now underpins our entire understanding of the structure of the universe. After that very controversial work of her PhD, she sort of wanted a little bit of a quieter scientific life, so decided to study something that should have been fairly straightforward. She decided to look at the speed at which stars are moving or orbiting around the center of a galaxy. It was thought they should be moving in a very similar pattern to what we see in the solar system, where planets close in orbit the sun much faster than planets further out. But Rubin found that the stars on the outskirts were orbiting just as fast as stars towards the center, suggesting that unlike the solar system, where the majority of the mass is concentrated in the center, in the sun, the majority of mass in galaxies must therefore be on the outskirts, despite the fact that the outskirts of galaxies are much fainter, i.e. have a lot less stars, than the centers of galaxies. This was one of the first pieces of observational evidence for the theory of dark matter, first proposed by Fritz Zwicky in the 1930s. Rubin's work concluded that galaxies must contain at least 5 to 10 times more dark matter than they did normal matter that was visible in stars and dust and gas, a result that's been confirmed over the past 50 years by a plethora of evidence supporting it. In 1996, because of her work, she then became only the second woman ever to win that prestigious gold medal awarded by the Royal Astronomical Society, 168 years after Caroline Herschel first won it in 1828. Next up is Gladys West, an American mathematician and space scientist born in 1930. She got her master's in mathematics in 1955 from Virginia State University before she was hired by a naval research base to analyze satellite data. And it was there that she found her passion for mathematically modeling the orbits of satellites and subsequently planets. It was that knowledge that proved invaluable to a 1960s study that actually showed that Pluto's orbit was actually tied to Neptune's, something we call resonance. During the 1970s and 80s, she worked once again with satellite data, but this time modelling the shape of the Earth and the Earth's surface. She modelled it as what's called an ellipsoid, a slightly squashed ball, taking into account the forces of gravity and tidal forces that were acting on it at any one time. That work formed the basis of GPS, the global positioning service that we now use, every single day? As was the way, though, for many African American women working in the sciences throughout the 20th century, her work went largely unacknowledged. She was finally recognized, though, as one of those hidden figures by the US Air Force in 2018 when she was inducted into their Hall of Fame. Next up, we have Dame Jocelyn Bell Burnell, who is a Northern Irish astrophysicist who was born in 1943. During her PhD at Cambridge in 1967, while she was using radio telescopes to study quasars, she ended up discovering a strange radio source that would pulsate, i.e. give out sort of a little pulse of radio waves every 1 1/3 second. This source was first dubbed LGM-1 by Bell Burnell and her PhD supervisor Anthony Hewish as a joke that it could be alien civilizations, i.e. little green men, LGM. But that hypothesis was quickly dismissed by Bell Burnell herself after she discovered a second similarly pulsating radio source at a different part of the sky not long after. After Bell Burnell announced this result, Fred Hoyle actually identified it as fitting with the hypothesis of a rotating neutron star, what were eventually dubbed pulsars. Now, the Nobel Prize in Physics in 1974 was awarded for contributions to radio astronomy and the understanding of pulsars. It went to Martin Ryle and Anthony Hewish, Jocelyn Bell Burnell's supervisor, but not to Jocelyn Bell Burnell, a decision which still causes a bit of controversy to this day. However, in 2018, she was awarded the Special Breakthrough Prize in Fundamental Physics, worth $3 million for this discovery of radio pulsars. But she very quickly donated all of that money to set up a scholarship fund for women, minority ethnic, and refugee students who wish to become physics researchers. She's now a visiting professor at Oxford, and she has an office just down the hall from me. It's one of the many, many privileges in my life that I am so grateful for. So there you have it, the 10 historically famous female astrophysicists that I somehow managed to narrow it down to, because that was just astrophysics. We could have covered all of physics, and then it would have been even harder to narrow it down. And I even couldn't have just focused on the historically famous astrophysicists. I could have talked about people that work in astrophysics today. Then we could have had people like Maria Goeppert Mayer, Chien-Shiung Wu, Willie Hobbs Moore, Shirley Ann Jackson, Mary G. Ross, Fabiola Gianotti, Deborah Ayaki, Maria Kirsch, Wang Zhenyi, Margareta Palmer, Svetlana Gerasimenko, Miriam Shadid, Shuangpei Ma, Maggie Ederin Pocock, Sandy Faber, Jedediah Eisler, Priya Natarajan, Ashley Spindler, Carly Noon, Meg Urey. And even with all of these additions, this completely non-exhaustive list, there's still people that can't name even a single female scientist, apparently. I mean, I do see this reflected in my comments on my videos as well. I see people commenting saying they are surprised, delighted, but also surprised that they found a female astrophysicist. The website True Sci-Fi lists 209 female astrophysicists alone. That's 209 of us talking about our work on a public forum every single day, and yet people are still surprised. And hopefully that link in this video will go some way towards challenging that surprise that pervades the public psyche, so that next time there's a survey done asking the public to name any female scientist, you're already with at least 10 that you can name right off the bat. It will recognize it because of the mnemonic that's mnemonic? Ugh, stupid word. Next up is Gladys West, an American recognized as one of those hidden figures by the US Air Force when she was abducted? She was abducted into their Hall of Fame. Jesus. So there's the 10 historically famous female astrophysicists. Can't even say my own title. All you women independent, throw your hands up at me. Girl, I didn't know you could science like that. Darling, how you science like that.